The red, parched earth under your feet is shaking. Large cracks are opening in the ground, threatening to swallow you. But unlike on Earth, these quakes aren't coming from within the planet. A threat coming from space is triggering them. Scientists have made a shocking discovery about Marsquakes. By using AI and NASA's InSight data, they found out that some of those tremors are caused by meteorite impacts. It means that Mars gets hit 2.5 times more often than we thought, and new craters are forming all the time. But the scariest part is that these impacts don't just shake the ground. They send powerful shock waves deep into the planet, revealing a hidden seismic highway and an unstable interior, unlike anything we imagined. This changes everything we thought we knew about Mars. So now, the big question is, what else is lurking beneath the surface? But let's follow scientists' train of thought first. They took Marsquake data from NASA's InSight lander and compared it with fresh impact craters spotted by the Mars Reconnaissance Orbiter. That's when they discovered that some impacts create a seismic highway through the mantle instead of being absorbed by the crust. Even though NASA shut down InSight in 2022, its data is still precious. The lander, which placed a seismometer on Mars, recorded over 1,300 Marsquakes, some caused by underground rock cracking under heat and pressure, others, apparently, by meteoroids slamming into the surface of the red planet. By studying how seismic waves move through the crust, mantle, and core, scientists keep piecing together Mars's deep structure. In the past, researchers already linked impact craters with seismic data. But these new studies are the first time when a fresh impact has been connected to quakes detected in Cerberus fossae. That's a highly active region 1,000 miles away from InSight. Scientists have discovered this 71-foot-wide crater much farther from NASA's InSight lander than expected, if we consider the strength of the seismic waves it produced. Mars's crust was thought to absorb most of the energy from impacts, which would limit how far seismic waves could travel. But the analysis of this crater revealed that, instead of getting dampened, the waves took a more direct and deeper path through the planet's mantle. This unexpected finding suggests that Mars has a seismic highway, which allows quakes to spread much farther than previously believed. Now, the InSight team will need to reassess their models of Mars' internal composition and structure. And then, we might better understand how impact-generated seismic signals can reach such depths. Manually sorting through the vast amount of data would have taken years. But luckily, these days, there are new tools, and scientists can go from tens of thousands of images to just a few in a matter of days. So, researchers focused on finding craters within approximately 1,800 miles of InSight's location. Their aim was to identify those that formed while the lander's seismometer was active. By comparing before and after images from the context camera over time, they identified 123 fresh craters to cross-reference with InSight seismic data. Out of those, 49 craters were potential matches for quakes detected by InSight seismometer. And after conducting some more analysis, the team decided that the 71-foot Cerberus fossae impact crater was the main finding. This discovery is likely to help scientists differentiate between signals from internal quakes and those caused by meteoroid impacts. Initially, they believed that Cerberus fossae produced a lot of high-frequency seismic signals linked to quakes originating inside Mars. But the new data suggests that some of this activity may have been caused by impacts, not internal processes. Another mystery scientists haven't been able to crack for 50 years is why Mars is split into two very different halves. But thanks to recordings of Marsquakes, they may have finally found the answer. Since the 1970s, researchers have known that Mars has two distinct regions. The northern lowlands cover about 2/3 of the planet's northern hemisphere, and the southern highlands make up the rest. The southern highlands sit about 3 miles higher than the northern lowlands, and the crust, the planet's outer layer, like a shell, is thicker in the south. This strange divide is known as the Martian dichotomy. There are two potential explanations for this imbalance. One theory suggests that an unknown internal process within Mars created the difference. The other claims that a massive collision, probably with a moon-sized space rock, or several smaller impacts once reshaped the planet's surface. But Mars' surface is extremely old. That's why pinpointing exactly what happened has been difficult. But now, a new study, published on December 27, 2024, has used Marsquake data from NASA's InSight lander to figure out whether the cause of this difference lies deep inside the planet. InSight was positioned near the boundary between the northern lowlands and southern highlands. Its mission included recording seismic data from Marsquakes, which travel through the planet's mantle, the rock layer beneath the crust. So scientists compared how these waves moved under both lowlands and highlands. They looked for differences in the planet's deep interior. It turns out that the seismic waves lost energy much faster when traveling through the southern highlands. It means that the mantle beneath this region is significantly hotter than in the north. It's compelling evidence that internal planetary forces, rather than an external impact, cause Mars' unusual split. The research team believes that the temperature difference between Mars' two halves can be traced back to ancient tectonic activity. It once shaped the planet, but later stopped. At some point in the past, Mars had moving tectonic plates, like Earth's. As these plates shifted, they, along with the molten rock beneath them, could have created the Martian dichotomy. But eventually, the movement stopped, leaving behind what scientists call a stagnant lid. That's a thick, immobile layer over the planet's molten interior. If this turns out to be true, it might mean that the mantle beneath the southern highlands is still pushing upward, while the mantle under the northern lowlands is sinking deeper toward the planet's core. This ongoing process could explain why Mars' crust is thicker in the south. At the same time, we can't completely rule out the idea that an external impact created the dichotomy. Some recent studies suggest that a giant collision could still be a possible explanation. To solve this mystery for good, scientists will need more Marsquake data and detailed models of how Mars originally formed. By the way, if you ever decide to visit Mars, you might come across the hero of our video today, the InSight lander itself. It was supposed to launch in March 2016, but a problem with one of its instruments caused a delay. It was a vacuum leak in the seismometer. NASA rescheduled the launch for May 2018, and the issue was fixed in the meantime. But this delay increased the total cost from $675 million to $830 million. Still, InSight successfully landed on Mars on November 26, 2018. But over time, dust built up on its solar panels, making it harder to recharge. The InSight lander runs on solar panels and batteries, but it needs occasional wind gusts, called cleaning events, to clear dust from the panels. Unfortunately, the place where InSight landed didn't get enough of these winds to keep the lander fully powered. By February 2021, during the Martian winter, thick dust had covered the panels, and they were only producing 27% of their full capacity. To save power, NASA started putting InSight into hibernation mode, shutting down instruments gradually to keep its electronics warm. They hoped better weather would allow the lander to recharge and wake up by July 2021. In May 2021, the team found a clever way to restore some power by using the lander's arm to move sand onto the panels, helping the wind clean off some of the dust. But eventually, InSight was only generating 1/10 of the power from the sunlight than it did right upon arrival. In July 2022, NASA put it in low power mode to keep detecting Marsquakes. The lander kept operating until December 2022. On December 20th, NASA announced that InSight had lost contact with Earth on December 15th, and the mission officially ended on December 21st, 2022. What if Martians came to our planet? What if a Mars rover brought back some unknown organism that began to reproduce and wipe out all life on Earth? Well, we've seen this scenario hundreds of times in movies and read about it in books. But in reality, the situation is the opposite. We are the threat. Humans are the ones that could infect another planet. We are the ones that could become the destroyers of Mars. And to prevent that from happening, countries created an international agreement that forbids us from taking certain actions on our red neighbor in space. It sounds like science fiction, but it's real. This agreement is called the Outer Space Treaty. It was signed in 1967 by the Soviet Union, the United States, and the United Kingdom. The treaty states that no country that signs it can claim sovereignty over any celestial body. It also contains many other important rules, but one of them directly addresses how we should search for extraterrestrial life. Now, there's a possibility that certain regions on Mars could potentially host life. However, according to the Outer Space Treaty, exploring these so-called special regions is prohibited. That sounds strange, doesn't it? Searching for life on Mars is one of the main goals of the entire space industry. So, how can these areas be off-limits? Well, the reason is contamination. When we explore these regions, we might accidentally bring life there. A tiny but extremely resilient microbe or bacterium could hitch a ride on a spacecraft, land on Mars, and begin to reproduce. But scientists are not only afraid that Earth's bacteria will destroy Martian life, there's a possibility that these two types of bacteria will mix, and we will not be able to separate one from the other. But what if it occurs that these bacteria were originally from Earth? Imagine NASA spending billions of dollars collecting samples of Martian soil, where life has been detected. The spacecraft brings these samples back to Earth. Scientists analyze them and suddenly realize that these Martian bacteria are actually ours. They had arrived on Mars 10 years earlier, when a robotic rover was simply taking pictures of the Martian landscape. Here on Earth, we already know bacteria that can survive extreme pressure, incredibly low and high temperatures, and even the complete absence of oxygen. For such organisms, adapting to Mars conditions might not be that difficult. But what if they change in that environment? What if they mutate and take on new forms? Scientists might believe they've discovered true alien life, when in reality, it's just Earth microbes that evolved on Mars. There's also a chance that Martian microorganisms could mix with Earth bacteria, making it impossible to separate them. In short, exploring places where life might exist could create massive scientific confusion. And what if contaminating Mars with Earth's life causes it to spread rapidly? What forms would that life take under conditions completely different from Earth's? Mars and the Moon can be explored, but it must be done with extreme caution to avoid biological pollution. And don't worry, the Outer Space Treaty also requires us to be careful not to bring potentially harmful Martian life back to Earth. So, what exactly are these special regions on Mars? Well, they're places where conditions might allow microorganisms to survive, which are warm and wet spots. But here's the ironic part. We currently don't know locations on Mars that meet these criteria. But if there are such places, we can't reach them. So in practice, this law about special regions hasn't really been tested yet. However, scientists also talk about uncertain regions. These are areas that could potentially be classified as special regions after further study. One example is recurring slope lineae, or RSL. These are dark, narrow streaks that appear seasonally on Martian slopes. At first, scientists believed these streaks were signs of liquid water. Later studies showed that RSL are formed by dry granular flows. So, does that mean there's no chance of finding life on Mars anytime soon? Perhaps. But what about all those headlines claiming that water was found on Mars? Couldn't that mean life exists there? Yes, scientists have discovered water, and it's not just small amounts, but entire oceans. The problem is that this water is buried 7 to 12 miles beneath the Martian surface. For comparison, the deepest hole ever drilled on Earth, the Kola Super Deep Borehole, is about 7.5 miles deep. We couldn't drill deeper on our own planet. Now imagine how much time, money, energy, and technology would be required to make a giant pit on Mars. For now, such a mission sounds more like sci-fi than reality. But let's say we do find a microbe on Mars and bring it back to Earth. What kind of danger could such a tiny organism pose? Well, science fiction thrillers give us dramatic answers, but there's also a real-world example. Take the fungus known as chytrid. This microscopic organism reduced populations of frogs, salamanders, and other amphibians across the globe. And this biological disaster affected humans as well. Chytrid is not an alien organism, but its story perfectly illustrates what can happen after even a small biological contamination. When chytrid infects a frog, it causes a severe disease. The fungus attacks the animal's skin, disrupting its ability to regulate water and electrolytes. Electrolytes are salts and minerals essential for biological functions. When this system breaks, it leads to heart failure. The frog doesn't survive, and the fungus continues to multiply and infect other creatures. The outbreak was first detected in northwestern Costa Rica in the early 1980s. From there, it spread south and east, reaching Panama in the 2000s. More recent research suggests that chytrid originated in East Asia and spread worldwide through the pet trade. How it evolved the ability to devastate amphibians is a story for another video. For now, let's focus on the consequences that still affect us even today. Over several decades, the chytrid epidemic caused massive declines in amphibian populations worldwide. Around 90 species disappeared entirely. The impact was especially severe in Costa Rica and Panama. As amphibian numbers dropped, so did the populations of predators that fed on frogs and salamanders. But that wasn't the main problem. Remember what frogs like to eat. They catch mosquitoes and various bugs. So after the fungus pandemic, the insect population increased dramatically. Now think about what is dangerous about mosquitoes. Yes, they bite and leave an itchy mark on your skin, but some species carry dangerous infections, such as malaria. As frog populations decreased, malaria cases among humans increased. Studies show that infection rates began rising about a year after amphibian decline started. Over the next 3 years, the number of malaria cases rose, but then stabilized. About 8 years after the chytrid outbreak began, malaria rates started to decline and eventually returned to previous levels. Does that mean frog populations recovered? Unfortunately, no. Amphibians are still struggling. It's possible that humans simply took stronger preventative measures against malaria, or perhaps other animals began feeding on mosquitoes. Either way, the ecosystem never fully returned to its original balance. This is the core problem with biological contamination. Damaging one species disrupts an entire system. Like a chain reaction, problems spread from one link to the next. If a simple fungus managed to affect life on Earth where humans can fight epidemics, imagine what a microbe could do on Mars. Even if life exists there, a single Earth organism could wipe it out completely. The reverse is also true. A Martian microbe could cause serious problems on Earth. Imagine a spacecraft returning from Mars and landing in the ocean. A Martian microbe jumps into the water and attaches itself to a shark. The shark begins to change into something terrifying and starts attacking other sea creatures. Fish become more aggressive and begin attacking anything that moves in the water. Mars's bacteria is multiplying. The fish becomes unsuitable for food. Fishing industry suffers losses, and many people begin to experience hunger without fish. Marine mammals disappear, and things get worse and worse. Okay, let's not be so dramatic, but you get the idea.
We just found the biggest clue ever that someone lived on Mars. Or should I say, something. Because if you're picturing skinny red extraterrestrials with big goofy eyes, forget it. The Martians we're talking about looked more like this, a tiny microbe. I know, a total bummer, but this could change everything. See that weird pattern on the rock? The one that looks like leopard spots? Experts think it was left behind by ancient life. And no, it's not like someone painted it, the way early humans drew on cave walls. These little marks could actually be leftovers from microbes, signs that some pretty wild chemical reactions were happening back when they were formed. And don't worry, we'll get to that in just a second. So NASA actually found this evidence over a year ago, and they were thrilled, as this was exactly the kind of weird rock they'd been hoping to see on Mars. They thought this weird pattern might be a biosignature, In other words, a clue that life was once there. That could mean an element, a molecule, some substance, or in this case, a funky leopard print pattern on a rock. But scientists were cautious back then. After all, you can't just go around shouting, "We found life on Mars," without being absolutely sure. It could have just been, well, a cool-looking Martian rock, right? So, they studied this sample again and again. And by they, I mean more than 1,000 scientists from NASA and partner institutions all over the world. And recently, they finally came out with a paper that basically says, listen, we can't find another explanation. And that's it. With no other explanation left, this might just be the best evidence we've ever had that something really did live on Mars. The sample, nicknamed Sapphire Canyon, was collected by the Perseverance rover in July 2024. It was taken from rocky cliffs along the edges of the Neretva Vallis River Valley, a region shaped long ago by water that once flowed into Jezero Crater. And we're talking like more than 3 billion years ago. Scientists believe that back then, Neretva Vallis was filled with rushing rivers carrying mud, sand, and gravel into the lake. When the water eventually dried up, it left behind the rocky outcrop where Sapphire Canyon was found. After collecting the sample, the Perseverance rover kept exploring the river valley to get a better idea of the environment where those rocks formed, and to figure out how those leopard spots might have appeared. That step matters because knowing exactly how the spots came to be is key to figuring out if the rock really holds signs of life. In other words, did those patterns form through normal chemical processes that don't need life at all? Or were they actually left behind by microbes? What the rover's instruments found is that the rocks in this area are made of clay and silt, which is exciting, because here on Earth, those materials are great at preserving signs of ancient microbial life. The rocks are also packed with organic carbon, sulfur, oxidized iron, and phosphorus. And you know who loves that stuff? Microbes. Experts think they could have used those ingredients as an energy source, and in the process, left behind the leopard spots we can now see in high-resolution images. Remember when I said these marks might be a microbe's leftovers, right? That's exactly it. Picture you're eating a burger called the Galaxy Burger that has a one-of-a-kind sauce. A drop of that sauce falls on the table. You don't clean it up, and a second later, poof, you disappear. Later, detectives show up trying to figure out if you were there. All they find is that sauce drop you left over. From that, they can tell exactly what you were eating. The Galaxy Burger. But proving you were really there is tricky, since that sauce could have ended up there in lots of other ways. The same goes for the leopard spots. Just by looking at them, scientists can already tell a few things. For example, the pattern shows the presence of two iron-rich minerals, vivianite and greigite. On Earth, vivianite often turns up in sediments near decaying organic matter, or in swampy, soggy wetlands. In a similar way, microbes can also produce greigite on our planet. When you find those two together, it looks like they formed through electron transfer reactions between the sediment and organic matter. That could be a fingerprint of microbial life, because microbes use those reactions to get energy and grow. So, going back to our burger comparison, the leopard spots are like the sauce on the table, the leftovers from the process of getting energy. But that's not the only theory. The team also spotted the possible presence of hematite in the rock. And if Mars has the nickname the Red Planet, hematite is the one to blame. It's a heavy mineral that can take on a reddish tone. On Earth, people have been using it as a pigment for paint for thousands of years. Now, scientists think the leopard spots may have formed when chemical reactions with hematite turned parts of the rock from red to white. That process can release iron and phosphate and possibly cause those black rings to appear. And here's the kicker. Those reactions can also provide an energy source for microbes. For now, though, these are just theories. What we can confirm is that those chemical compounds are definitely present in the rocks. But just like in the detective story, finding the sauce drop doesn't prove it came from you. So even though these materials are great for microbes to thrive on, it doesn't automatically mean this is a biosignature. They could have also formed abiotically, or, put simply, without the presence of life. Yeah, it could happen, but for it to happen naturally, without microbes involved, you'd need two things: high temperatures and acidic conditions. That's the only way those chemical processes could do their magic and leave behind the leopard spots. And here's the exciting part. Scientists didn't find any sign that these Martian rocks were ever exposed to high heat or acidic conditions. That's why I said they're stumped. They just can't find another explanation. So this has to be a biosignature, right? Well, maybe not. Because there's still a possibility that organic compounds could react even under low temperatures. And maybe, just maybe, we're seeing that happening for the very first time. That's why it's so hard to confirm 100% whether this is the handiwork of ancient microbes or just a natural process. So, in the end, we're still left with more questions than answers. Right now, this precious sample is safely sealed inside a tube millions of miles away on Mars. Hopefully, one day, it'll be brought back to Earth so scientists can study it in labs here. And while we can't confirm it's a biosignature just yet, one thing is certain. This finding by Perseverance is the closest we've ever come to discovering life on Mars. Honestly, just being able to spot a potential biosignature on the red planet is already groundbreaking. Another reason this finding matters has to do with the age of the rock. This evidence comes from some of the youngest sedimentary rocks we've ever studied. Until now, scientists thought that if we ever found signs of ancient life on Mars, they'd most likely be locked inside much older rocks. But so far, nothing has shown up in those ancient formations. Finding a possible biosignature in a young rock suggests two things. First, Mars might have been habitable for longer or later in its history than we ever thought. And second, older rocks might also hold signs of life, but maybe they're just harder to spot. Someday, our technology could be advanced enough to find them. This discovery also makes us think about one of the biggest questions of all, and that is, are we truly alone in the universe, or did we just find the answer? No, not exactly, but it's the closest humanity has ever come to answering that question. There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the Red Planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild.
NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the Red Planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the Red Planet back in its old times. There's this story about an ancient mega-flood that might have happened there. So yes, the Red Planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that? You know, it's hard not to wonder if there's another form of life out there in the universe when you look up at the night sky. There's this thing called the Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof that there are other forms of life somewhere in space. And we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So, it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, the Fermi paradox basically says, hey, where's the party? How come we weren't invited? And one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development and then something happened that destroyed them, like an asteroid impact or an environmental disaster. Or they could cause their own demise, and bam, everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Well, woohoo! But it would also mean that intelligent life is relatively rare in the universe and that we may be the only advanced civilization that exists at the moment. So, the universe could really be relatively empty when it comes to intelligent life. That means the chances that we'll make some friends from other planets and visit them in our super cool spaceships are low. Well, that's sad. But the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really does lie in our future, it may mean there are many intelligent civilizations out there, but they're all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter Theory talks about is the development of artificial intelligence, or AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity, or lead to unwanted consequences if we're not careful enough with it. There's still hope, though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Well, either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took pictures of geysers of frozen water that were spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is a key element for development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life, and it plays a very important role in many biological processes, such as cell membrane formation, energy transfer, and such. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life, Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere that you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes, filled with methane and ethane, liquid natural gas, but still. Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the Sun, though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. Now, we can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They also have found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbits Jupiter. It potentially has plenty of water, too. There could be a salty ocean under its nearly 10 miles thick crust with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents, too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geological inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the Moon formed, which is why it gives us a unique window into the early history of the solar system. And, you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh?